Hello students, today we'll do a coordinate geometry set. This would work for both the SAT and the ACT math sections. If you're doing this as an SAT set, you can use a calculator. Question 1. A vertical line divides the triangle with vertices 0, 0. Okay. So one vertex is the origin, C9, 0. So that's here. And D8, 4. So that's here. Into two regions of equal area. Okay, so this is a triangle. And there is a vertical line. Let's say this is my vertical line. X equal to C into two regions of equal area. Find the equation of the line. Okay, so let's first quickly find the area of triangle OCD. That will be half into base into height. The base here is 9, right? And the height here is 4. So that's just 18, right? So which means that if I say that this is M and this is N, then area of triangle OMN should be 9, because the area of OMN and the figure to the right, NMDC, they are equal. Each of them is half. So then OMN should have an area of 9, because the big triangle ODC has an area of 18. Now, how can I find the area? Obviously, if this line is x equal to C, then this point will be C, 0, which means this distance is C, right? So I already know the base of this triangle. To find the height, I need to find the coordinates of M, right? For that, I need the equation of the line OD. So what is the equation of line OD? It will simply be y is equal to mx, right? Because it passes through the origin, so the y-intercept is not there. And m will simply be 1 by 2, right? 4 by 8, so 1 by 2x, right? Now, if y is 1 by 2x, then this point, whose x coordinate is c, will have a y coordinate of c by 2, right? Because this point lies on the line, and for this line, the y value is always half of the x value. The x value is c because this point lies on this vertical line, and so the y value is c by 2, which means that this vertical distance from M end, this vertical distance is c by 2, right? And so now I can find c, half into base, which is c, into height, which is c by 2, is 9, right? Because in this triangle, the area is 9. So c square is 9 into 4. So c is 3 into 2, which is 6, right? So the equation of this line is x equal to 6. That's what we have to find. Okay, let's go to the next question. Find all values of c such that the line y is equal to x plus c is tangent to the circle x square plus y square is equal to 8. Okay, so let's first look at the circle. 1 second. Let me draw a proper line here. So my circle is at the origin. X squared plus y squared is 8. So it is centered at the origin. And its radius is square root of 8, which is 2 root 2. So let me draw a circle like this. So this point is 2 root 2 comma 0. This point is 0 comma 2 root 2 and so on. Now I have to draw a line y is equal to x plus c which is tangent to this circle. So let me try and draw that. I can have two such cases, right? One line could look like this. And the other line could look like this, right? So I would have two possibilities. So they are tangent, right? Now, how do I find that? I know that the circle and the line should intersect at one point only. So I'll put the value of y from the line into the equation of the circle. So I'll get x squared plus c whole squared is 8. So x squared plus 2cx plus c squared is 8. So 2x squared plus 2cx plus c squared minus 8 is 0. So this is a quadratic in x, and I know that I want just one solution to this quadratic because I want the line to be tangential. It shouldn't intersect the circle in more than one point. So for a single solution, the discriminant has to be 0. And the discriminant is defined as b squared minus 4ac for any quadratic equation. And that has to be 0. So when I say b squared minus 4ac is 0, my b is 2c. So 2c whole squared minus 4. My a is 2, so 2. And my c is c squared minus 8. So I get 4c squared minus 8c squared plus 64 is 0. So I get minus 4c squared is minus 64. So c squared is 16, right? Which means that c is plus minus 4. So y is equal to x plus 4 and y is equal to x minus 4 are the two lines that will be tangential to the circle. X squared plus y squared is equal to 8. Okay, let's go to the next question. Find all values of k so that the circle with equation x squared plus y squared is k squared will intersect the circle x minus 5 whole square plus y plus 12 whole square is 49 in exactly one point. Okay, so I have this circle. This circle has the center at the origin and has a radius of k. Okay, and this circle has the center at 5, negative 12 and has a radius of 7. Okay, so 1 second, I'll write this properly. Radius of 7. Okay, so I'll just try and let's say this is 5 and this is negative 12. Yeah, and the radius of 7, right? So this was 5. Wait, it has to be a little, I'll just, probably I should redraw this because I need to be in the 4th quadrant. So I should make the 4th quadrant bigger. So I'll probably do something like this, right? Yeah, that would make sense. So this is 5 and this is negative 12, let's say. So and 7, right? So 7 is my, this is how it would look, right? This point is 5, negative 12 and my radius is 7. Now, if I have a circle centered, I can have tangent like this, right? I can have a tangent like this, or I can have a tangent like this. Right? So a circle centered at the origin can be tangential like this or like this. So I know that if this is tangential, this is k, and I know that this is 7, right? Because the radius is 7. And what is the distance of the center of this circle from the origin? That distance would simply be under root of 5 squared plus 12 squared, which is under root of 25 plus 144, under root of 169, which is 13. So I know that, let's say this is O and this is O dash. I know that O dash is 13. In which case K will be 6, right? Because the distance from O to the O dash is 13, and part of that is the small circle radius and part of that is the big circle radius. So the small circle radius is 6. And what if the other K value, right? So let me remove this. Let me remove this K. This K can go. Yeah. And what about the other K value? The other K value when it is externally tangent, right? As in rather internally tangent when that. Then this is 7. We know that O dash is 13 plus 7, another 7 for this circle, right? So the other one value of K was 6 and the other value of K will be 13 plus 7, which is 20. So actually this question we could solve simply from the graph by drawing the circles and seeing what would happen if the circles were tangent externally and internally, right? So one value will be K is equal to 6. The radius of one circle would be 6 and the other would be, this would be 13 plus 7, which is 20, right? I think algebraically, if you had tried to solve this, so we already have an answer. So let's see if we can try and solve this algebraically. Yeah, so algebraically, if you had tried to solve it, you would have had to substitute one value, one variable from one equation to the other. So let's say I substitute y is under root of k squared minus x squared in this other equation. So I get x minus 5 the whole squared plus under root of k squared minus x squared plus 12 the whole squared is 49. And this would get quite complicated when you expand it because you would have a square root term, right? And you would have to keep solving that. So I think in this particular question, it was simpler to solve it graphically. So I'll just show you the next step here. X squared minus 10x plus 25 plus k squared minus x squared plus 144 minus 24 times square root of k squared minus x squared, and that's 49, right? So we have squared x minus 5 and we have squared this. And you see it's getting a little complicated looking now, right? So it's just better to do this graphically. Okay, so that was question 3. Okay, a circle intersects the axes at, so let's draw this circle. Okay, so it intersects the axes at 0, 10. So let's say this is the origin, 0, 0 and 8, 0. So my circle will look something. Oh, so then this has to be the diameter, right? Because if it is intersecting these 3 points, then I can see that this will be the diameter, because the angle in a semicircle is 90 degrees. And since this is 90 degrees, AB becomes a diameter, which means that the center of the circle will be the midpoint of AB, which was 4, 5. Let this be C. So this is 4, 5, right? Now a line passing through 2, 3 cuts the circle in half. Okay, so let's say this is 2, 3, it cuts the circle in half. So if it has to cut the circle in half, the line must also pass through the center. So let's say this point is M. So the line will look like this, right? It would have to pass through the center to cut the circle in half. So M is 2, 3. What is the y-intercept of the line? So that's pretty simple. We can just solve and find the line. So y minus 5 is 2 by 2 x minus 4, right? I use the slope point formula, y minus y1, where y1 is 5, is 5 minus 3 by 4 minus 2. So 2 by 2 into x minus 4. So y minus 5 is x minus 4. So y is x plus 1. So the y-intercept is 1, right? That's all. So this was a good question because here, the fact that the triangle, that the circle was passing through A, O, and B meant that AB would be the diameter, since angle O is 90 degrees. And since we know that AB is the diameter, we can find the midpoint, which will be the center. And now we need to find a line that cuts the circle in half, which means that the line will have to pass through the center, and it already passes through 2, 3. So we find the equation of the line. Right, so this was a coordinate geometry set. If you found this useful, please hit the like button and subscribe to the channel. I'll see you guys in a new video soon. Take care. Bye-bye.